Let us come to the practice problems. Write down the formula of the following coordination compounds. The first one, potassium tetrahydroxyzincate. Potassium, that is K. Tetra means 4. Hydroxo means OH. Zincate means Zin. Okay? So here, first we have to identify whether the simple ion or the counter ion is an anion or a cation. Obviously from here it is the what? Your simple ion, or it is the anion, sorry, cation is potassium K plus. After that, identify the coordination entity, this one. And then we have the anion, which is the coordination entity. For this part, write the symbol, okay? So first write the central metal atom, Zn, followed by the ligands, tetrahydroxo, that is tetrahydroxo. We want to find the charge carried by this coordination entity. Your X would be the charge on the central metal atom. What is that? It is the oxidation state, plus 2, plus 4 into the charge carried by the ligands. It is minus 1 charge carried by OH. So what is your X from here? Your X is minus 2. So you get your X to be what? You get your X to be minus 2. So look here. We see that charge on one cation is 1. Charge on one cation is plus 1. Charge on one anion is minus 2. So that means I need, instead of K plus, we need 2K plus, so that we will get plus 2. Okay, so that this one will get cancelled with this, and hence the compound will become neutral. Yes, so that's why the formula now, the formula for the given compound is what? First we have to write potassium. Okay, potassium, and then write then the coordination entity SnOH4. Look here, we got here minus 2. Okay, so this is for the coordination entity, so that is for the counter ion, it should be 2, so that the compound will become neutral. So hence follow the same thing for number 2. For number 2, identify the what? The simple ion, whether it is a cation or anion. Obviously from here, this is your sulfate, iron, aqua means H2O, hexa means 6. Here the simple ion is or anion. What is our anion or the simple ion? It is our sulfate, SO4, 2 minus. Then we come to the coordination entity or the cation, iron. Okay, write first the central metal atom. It is Fe, hexa aqua iron. Okay, and then we want to know the charge on the coordination entity. So our X would be, what is the charge of Fe or the oxidation state? It is plus 2, plus 2, plus 2, plus 6 into the charge of H2O. It is 0, it is neutral. Okay, so our X would be what? Plus 2. So we get our X to be plus 2. Okay, here we have plus 2, and look here, we have minus 2. Charge on one anion, what is the charge on one anion? It is minus 2. And charge on one cation on the coordination entity, it is plus 2. Now they are balanced, right? Minus 2 and plus 2 gets cancelled, so that the compound becomes neutral. So hence what would be the formula? Let us come to the formula. Therefore, the formula for the given compound is what? You have to write first the coordination entity according to what they have given. Okay, so hexa aqua iron, and then sulfate. Okay, they are balanced, so nothing to write. So now let us come to the third one. The same thing here. What you have to do, this one is potassium hexacyanoferrate. Okay, so here identify which one is a simple ion, whether it is a cation or an ion. Obviously it is a cation, so our simple ion is our cation. Our simple ion is our cation, that is K plus, and then we come to the coordination entity, that is hexacyanoferrate. Okay, hexacyanoferrate. Write first the central metal atom followed by the ligands. Hexacyanoferrate. Okay, so we have here X. We want to know X. So what is the oxidation state of iron? From what they have given, it is +3, and then +6 into the charge carried by Cn is -1, so we get our X to be what? -3. So it is -3. Okay, so charge on one cation is how much? It is +1, right? +1. Charge on one anion on the coordination entity is -3. So that means we need, here it is only for 1 K plus. So in order to be balanced with this one, we need 3 K plus, so that we will get +3, and this one will get cancelled with this, and thus will make the compound what? Neutral. So thus the formula for a given compound is, write first the cation, potassium, and then leave some space, write the coordination entity FeCN6. Okay, so what should I write here? It should be 3. Okay, why? Because this one will dissociate as 3K plus, and FeCN6 3 minus, okay, they get cancelled and the compound is neutral. So this is how we find the formula of a given compound when the name is given.